Hello students, today we will discuss a very nice interfacing diagram for PIC microcontroller wherein we are going to blink LED, okay, but by using a different logic. We are going to make use of interrupt, okay. So this is the hardware I have already prepared in a Proteus ISIS simulation software. You see here I am using PIC 16F877 and to the RB0 pin I have connected one button, okay, and it is pulled up to the VCC through 10 kilo ohm resistor and one end of it is connected to the ground. So when I press this button, initially when this button is open, then the VCC supply is going directly here. That means 5 volt is directly applied through this resistor to this pin. That means this pin is active high. And you see very carefully, this is interrupt pin. Okay, so RB0 is an interrupt pin. Okay, so there is a active high logic. Once I press this button, okay, this active high logic will go to active low, okay, and therefore there is high to low transition and thus there is interrupt occurs. So when external interrupt occurs, then how PIC microcontroller works or how PIC microcontroller actually works for this particular interrupt, that I will explain in this presentation. So you see I have connected here two LEDs. So one LED is connected to pin number RC0 and another LED is connected to pin RB1. Okay, so what am I going to do is when I press this button, then this LED will glow for 5 times and then it turns off and this LED will turn on. Okay, again when I press this button, this LED will turn off and this will blink for 5 times. So this is what my logic that I want to show over here. So for that I am going to use this interrupt resistor. Okay, so intcon resistor, interrupt control resistor, is the main resistor that I am handling in this case. So it is a 8-bit resistor. You see all these bits, and these all bits are read writable bits. Okay, so bit number 7 is GIE bit, stands for global interrupt enable bit. When this pin or when this bit is 1, it enables all interrupts. Okay, that means when this pin is high, then all interrupts are activated and allowed in PIC to entertain. Okay, when this GIE pin is made 0, then no interrupts are allowed and PIC will focus only on main program. Then the next bit is INTE bit number 4. This is of very interest. Okay, so this is external interrupt enable bit. So when it is 1, then it enables the external interrupt pin, and when it is 0, then it disables the external interrupt pin. Okay, then RAI bit number 3 is a port A change interrupt enable bit, and INTF is a interrupt flag bit. Okay, so when interrupt occurs, then this flag bit will go high. This timer 0 interrupt flag bit is related with timer 0. This timer 0 interrupt enable bit is related again with the timer 0, so that will not discuss over here. So only these 3 bits, GIE bit, let me highlight it. So only these 3 bits we are interested in: GIE bit, then INTE bit, and third one is INTF bit. These 3 bits we are interested while programming this interrupt logic. So let me quickly explain this logic and download the program in simulation and show you how it works. So, okay, for that I am using micro C compiler. You see this is my program. Okay, so let me minimize this so that we can watch all the entire program. So here I have defined one variable, unsigned integer I. Then I have written one function over here, a blink function. This function will blink for 5 times. See, I am using a variable I, and I is varying from 0 to 5. So till I is less than 5, it will work. So I varies from 0 to 4. That means 5 times the LED will turn on and off. Okay, so I have used port C dot RC0 means pin number 0 of port C. You see in the interfacing diagram I have already explained you this LED I want to toggle for 5 times. Okay, so for that I am using RC0. Okay, so port C dot RC0 pin. All right, so this is what I have written over here, port C dot RC0 I made initially equal to 1. I made it high, then I called a delay of 200 millisecond, then again I made it 0, and again I called a delay of 200 millisecond. Then this is the interrupt routine. We'll discuss it later on. Before that, let me explain this main logic. So here tris B is equal to 1. Why I have defined this tris B equal to 1? The reason is that tris is a direction setting resistor which is used for ports in PIC microcontroller. So this when tris B is set to 1, it means port B is used as an input port. When this tris B or when this tris resistor is set to 0, it means the port, that particular port, will be used as an output port. Since I have defined this tris B is equal to 1, I am using this port as an input port. Then tris C is equal to 0, I am using port C as an output port. Now, as I said earlier, I am making this global interrupt enable pin equal to 1. As I said here, this bit I have made equal to 1, which allows interrupts to occur in the main program. That's why I made it equal to 1. Then intcon.int is equal to 1. It allows external interrupt to occur. So that's why I made this pin equal to 1. Now, this is my main logic. While logic. While 1 means while true condition port B RB1 is equal to 1. Now what is port B RB1? Port B RB1 is nothing but the LED which is connected to port pin number RB1 of port B. Okay, so that's why I have written here this LED should go high. Okay, so this will remain high unless until interrupt will occur. So when interrupt will occur, then the RB0 pin will go from high to low, and it will detect that external interrupt is occurred, and then it will jump to this interrupt logic, interrupt function. Then it will come at this interrupt function, and at this interrupt function it will check whether this INTF flag is set or not. That means whether interrupt has occurred. So here already we have put the condition that INTF is equal to 0 because there is no flag set till, and when we press the button, then and then only the flag will set. So when interrupt occurs, this is high. So when this condition is true, we are making this LED 0. So when this condition is true, when INTF is equal to 1, it goes inside, it makes this LED 0, and then it will call a blink function. In blink function, we have already written that a port C LED will toggle for 5 times. Okay, then it will come out of this, then global interrupt is made 1 again, and then this flag is made 0, and then it will come out of this. Okay, so this is what the main logic, main program that I have written. Simply you execute, build this program and download its hex file into the microcontroller and try to run this. Okay, so for downloading, double click on this, you click on this folder and select this interrupt blink.hex file, open it. Okay, click on OK, and then simply run your program. Now see, both LEDs are on since I have made this RB1 pin is equal to high. Okay, that's why both LEDs are high. Now when I press this button, what will happen? See, when I press this button and release, then interrupt will occur. This LED goes off and this will blink for 5 times. Again you see, this will be high, it will blink. Okay, the same thing will repeat. Okay, if I want to reverse these things, if I want to reverse this, okay, then how I will change this program? Simply instead of RB1 is equal to 1 in the main, I will make it 0. Okay, and here in this interrupt logic I will make it equal to 1. Okay, this simple change will change the functioning of the program. Now you build it, compile it. Okay, Again, you download the program, double click, select the LED interrupt X5, ensure the clock frequency 8 megahertz, click on OK, and now run it again. Now you see here your LED is initially off. Initially in the previous case it was high. Now when I press it and release it, now it is high and it blinks for 5 times. Now it is off. Okay. Again if I blink it, again it will blink for 5 times and then it will stop. Alright. In this way the PIC microcontroller interrupt logic will work. Okay. Thank you very much.